Hey guys, Charlie here. Today we're going to be building a very simple calculator in Python. I guess there is a very slight advanced part to it, but it's pretty simple overall. Let me know in the comments if you guys would like me to make a GUI version, as I will. Just let me know. Alright, getting straight into it. To start, math functions, right? So each are going to take two numbers. So we need So we need to the add one, right? So then we're just going to return a plus b, right? Same thing with subtract. A times b, right? So for all of them, except divide. Divide is a little tricky. If you open up a calculator, right, and you try and divide something by 0, you can't. So we need to account for that. So if b is equal to 0, we're just going to raise an error. Cannot divide by 0. And then we're just going to return a divided by b. All right, all pretty simple there. Next, we need to tokenize. So we're actually going to import the regular expressions library, which I'll explain what those are in a second. It's regular regex is short for regular expressions. So I'm just going to be saying that. So we need to tokenize, right? A token is basically a piece, so a number or an operator. So we're going to need this regular expressions library so that we can match patterns in the text, which I'll show you guys in a second. So we're just going to make a tokenized function. And then before we do anything else, we want to replace any spaces that people may put and then strip any white space on either side. So basically, if somebody types 2 plus 2, we want it to work, right? Plus 3, right? But if they type 2 plus 2 plus 3 and have spaces there, we want to just remove those spaces because obviously we know what they mean. We don't want it to error at them. So then basically what we're going to do is if not expression, raise value error, empty expression. So basically what this is saying is if the string is empty input isn't invalid. So if you've ever seen \n and how it creates a new line, right? This R just prevents that, so it won't break out because otherwise normally in regex you'd have to put 2. I want to make it easier to explain. I'm not going to put 2, so I'm just putting this so I can just put 1, right? What this is doing is this first D is just a number, right? It's a digit, and then this is saying maybe a dot, and this is saying maybe more numbers after that. So this entire expression is basically just saying one or more digits, maybe a dot, and then maybe there's more digits. So this accounts for both integers, whole numbers like 2, 3, 4, but also decimals like 3.14 or whatever. What this is saying, this is just it's just like a bitwise OR. And then what this is saying is it's one character that is a plus, a minus, an asterisk, or a forward slash. And the reason you have to put this backslash here is in regex you can put A to Z, right? So that minus sign is normally signifying a range. But then moving on next, we're going to need to make a list because the tokens is where we're going to hold everything. And also same thing with an index. Next, we need to loop through every item in that in parts, right? We're going to do while I is less than the length of parts. Basically, this is just saying until we've seen everything. Then we're just using I to step through everything. So we're going to use P with the index of P is equal to parts with the index of I. So P is just going to be the current piece that we're looking at. And then next we're going to need to know when is the minus sign a negative sign for a number or instead of subtraction, right? So basically when it's at the very start, tokens is empty or right after an operator, tokens minus 1 is going to be the last thing we added. It's going to be, if it's a plus, minus, times, or slash, then the next part is going to be the number. So we take it and make it a negative. And then if P is an operator, keep it as a string in our list. So then otherwise P is a number. P is a number string like 2 or 3.14. So we're going to convert it to a float. Also, we're going to just want to move to that next position in parts. In any sense, a valid expression like this is going to alternate number, operator, number, operator. So we're going to need to make sure that there's an odd number of tokens. So basically what this means is if the remainder of the length of tokens when you divide it by 2 does not equal 1, then we're going to raise an error, right? invalid expression, because we want to make sure that there is an odd number of tokens, because, you know, otherwise, you know, somebody could put like 2 plus, right? And if you have 2 plus, doesn't mean anything, right? All right, next we need to do our operations, right? So basically we want to walk left to right. Whenever we see number, operator, number, with operator that is in operators, we're going to replace with the result. So we're just going to make a new list so that we don't have to change tokens. We have a fresh list, and then we're going to make an index. And then we're going to keep going until we've looked at every position in tokens. So just like we had earlier. And then we need to make sure, do we have at least 3 items left? And is the middle one an operator in operators? So basically what this is saying, right, is do we have at least 3 items left? And is the middle one an operator? So if it is, we're going to grab the 3, the left number, the operator, and the right number. Then what this is all saying is we're going to just actually do the math and append the result to out. And then because we used 3 items, we used 2 numbers and an operator, we're going to move forward by 3. And then if it isn't a number, operator, number, we're just going to copy this item and move it by 1. And then once it's made it all the way through, we're going to return out. We're going to return this new list, right? So what this is kind of saying, right, it would take that first group of 3, right? So 4, so it'd have 8. And then you'd have 8 plus those, right? And then it would do it again with these 3, and then it would keep going down. So that's like the rough concept around it, right? But that does not account for PEMDAS. So now we need to evaluate. So what we want to do is we want to copy the list because we don't want to change that original one. So basically now we want to do multiplication and division first from left to right. So first we want to do multiplication and division first because PEMDAS, right? So we're going to just have it evaluate multiplication and division first. And then we're going to have it do the same thing, but with addition and subtraction. And then once we're done, we're just going to return tokens, but we're going to return, the 0 is basically saying this list by the end of this, because we're doing all of the operations, should only have 1 item left. So we're just going to return that item. And perfect. We're basically done. So now we're going to make that last main function, right? We're going to ask for the expression, tokenize, evaluate, and all that good stuff, right? So to start, when the program first starts, we're going to print out calculator, okay? And then we're going to do type an expression or quit to exit, right? And then we want to make the loop because it'll go through this. We want it to see while true because later we'll make it so the quit cancels out of this. Then we need to get that user input because like we've done all this, but we have not actually asked a user for their input yet. Input, and this is how you get an input in Python for anything. And then we want to strip any white space in case they add any leading or trailing spaces. We want to check, you know, because we have that quit. If they want to exit the program, they type quit. So if user input dot lower, so this way by adding dot lower, it'll be, you know, if they type quit or you know, any of them, it'll just make them all lowercase. So then we're just going to print by, and we would break out of this. And then we also want to make sure, like, what if they accidentally just hit enter? We don't want the program to just die, right? So if not user input, continue. So then we're going to make a try, and result equals evaluate, and then tokenize that user input. And then we need to actually print out our result. So then if there's some sort of error, like a bad input or divide 0, we want to just print that error out. So, and then perfect. And I think that actually should be it. So, okay, so I actually just found a bug that I didn't account for, and I sat here so confused. What I had was this, right? What we actually need to do is we need to make this a loop so that it does it through all of them, right? Because before, what it would do is every time you do like 4 plus 4 plus 4, it would give 8 instead of 12. It wouldn't continuously do it. It would only go through the 1, right? So, yeah. But other than that, okay. Sorry about that. Anyway, it should be all good. So, you know, now we can go ahead and rerun it. Got our calculator, type in expression or quit to exit. So 4 plus 3, 3 plus, you can do whatever amount. You can do whatever amount, but like if you type 2 plus or plus 2, invalid expression. So see if I type a U, it'll just ignore it. Or if I do like that, invalid expression. And yeah, I mean, everything everything works well, works properly. So if you guys enjoyed, make sure to hit the like button and subscribe, and let me know if you guys want the GUI version of this calculator. It's definitely a bit more confusing, but it's very good for learning. So let me know in the comments, and have a good one.